This video has been produced and distributed by the North American Die Casting Association to assist in improving safety in die casting facilities. The injury rate for the die casting industry is approximately 2 times the rate of other private industries, as reported by the U.S. Bureau of Labor Statistics. Several hazards exist in die casting facilities that can cause serious injuries such as burns, slips and falls, strains and sprains, eye injuries, fractures, and cuts. You should pay very close attention to the detail presented in this video and follow all safety rules established by your plant to prevent injuries to yourself and others. Heat from molten metal, castings, die casting machines, die casting tools, hot oil, chemicals, flash from castings, the wrong mix of materials, poor housekeeping. Studies show 96% of all accidents are caused by unsafe acts, something somebody didn't do correctly. That means most accidents are avoidable. Failure to perform your job in a safe manner isn't an option. There's simply too much at stake when you let safety slide. Safety is everyone's responsibility, and this video will help you do your part by providing communication on lockout-tagout procedures, personal protective equipment, metal melting and handling, die casting machine guarding, hazard communication, and housekeeping. One of the worst die casting disasters of all time happened because safety procedures weren't followed. People died. People were seriously burned and injured, and people lost their jobs. More common to die casting operations, but no less important to avoid, are sprains and strains, bruises and cuts, fractures, and heat burns. Because simply, it's good business when everybody stays healthy and injury-free. Sprains and strains are usually caused by overreaching and improper lifting. If a job requires moving heavy material, ask for help and use the training you've been given to avoid sprains and strains. Bruises and contusions are often caused while using hand tools or by moving machine components. If you're working around moving equipment, keep your hands, arms, and body from harm's way. Don't place your hands or arms over, around, or through safety guards. And when handling castings that are heavy or have sharp edges, use caution and wear proper personal protective equipment. Fractures are always caused by slips, falls, and moving equipment. That's why it's always important to keep your work area clean, organized, and free of water and oil. And use caution when you're working on equipment, especially above the machine platform, and don't reach around machine guards. Die casting dies, hot motors, hydraulic pumps, hoses and piping, molten metal holding furnaces, and transfer ladles get hot and can cause serious burns. Wear personal protective equipment when working with or around hot materials, and keep a safe distance from molten metal to avoid being burned from splashing metal. If you handle castings, wear the right kind of gloves. It only takes a moment for a serious burn to happen, so assume that all castings are hot, because you can't tell by looking at a casting whether it's hot or not. Every employee in a die casting operation must be trained concerning the safety rules to work safely, to audit their work area for safety hazards. They should correct or report safety hazards and to watch out for their co-workers' welfare. Identifying, reporting, and correcting unsafe acts and conditions greatly reduces the potential for accidents, injuries, and damaged property. OSHA's lockout-tagout standard helps ensure safety on and around powered equipment. This OSHA standard identifies 3 classifications that determine to what extent employees are affected by lockout-tagout requirements. Authorized employees are the ones who lock or implement a tagout system procedure on equipment for servicing or maintenance. Authorized employees must have thorough knowledge of the machines they work on and the lockout-tagout requirements that go with them. The affected employee is one whose job requires them to operate or utilize equipment and understand lockout-tagout requirements to avoid hazards for maintenance personnel. Other employees are those whose work may require them to be in the areas where energy control procedures exist. They are not directly responsible for operating or performing maintenance on equipment. Lockout is the preferred method of control and provides the greatest degree of protection for the employee working on the machine. If work is required on equipment that will not accept lockout devices, tagout is permitted. All lockout-tagout procedures must be followed even if no one is in the work area when the work begins. Many times, employees enter the work area after maintenance procedures have begun, and lockout-tagout procedures ensure that these employees do not accidentally energize the machine. The fundamental rules that everybody must understand about general energy control procedures are that all equipment must be locked out or tagged out to protect against accidental or inadvertent operation, and that no one should attempt to operate any switch, valve, or other device that is locked out or tagged out. To perform a lockout or tagout under the general energy control procedures, 1. Notify all affected employees. 2. Deactivate the equipment to be serviced using normal shutdown procedures. 3. Isolate the equipment from its energy source. 4. Lock out or tag out all energy isolating devices on the equipment. 5. If the maintenance procedure involves more than one person, each person must place a personal lockout or tagout device on the energy isolating device. For multiple locks, a multiple hold hasp must be used. 6. Make sure all personnel are not exposed to potential injury from the equipment. 7. Check the zero energy state of the equipment by attempting to operate the equipment to ensure that it will not operate. Return all controls to neutral or off after trying to operate the equipment. When the service or maintenance job is done and prior to starting the machine, employees must first remove all tools and reinstall machine guards. Check the area around the equipment so that no one is in an exposed area. Remove all lockout-tagout devices. And operate the energy isolating devices to restore energy to the equipment. Specific energy control procedures affect most equipment used in die casting operations. They include identity and description of each item of machinery or equipment, the listing and description of controls and sources of energy, shutdown procedures in a step-by-step manner, and procedures for releasing the machine from lockout or tagout and for starting up the equipment must be provided. Training on lockout-tagout procedures vary according to employee classification. Authorized employees must be able to recognize hazardous energy sources and the type and magnitude of energy at the job site, and how to isolate and control them. Affected employees must understand the purpose and the use of energy control procedures or equipment they operate, or where the energy source is located in their work area. Other employees should also be trained on energy control procedures for equipment they operate and be prohibited from restarting equipment that is locked or tagged out. OSHA requires the use of personal protective equipment to help keep employees safe. Management and shop floor workers as well must understand what personal protective equipment is available and how to properly use it. Basic personal protective equipment that should be worn by everyone working in the die casting area of facility includes safety glasses with side-eye protection. Eye and face protection must cover the front and the side of the eyes and face and includes safety glasses, goggles, face shields, welding helmets, and full hoods. Employees who wear contacts or glasses must wear goggles or other eyewear meeting ANSI standards or prescription safety glasses. Face shields and welding helmets are considered secondary protection. They must always be used with safety glasses or goggles in order to provide adequate protection. Long-sleeve shirts and pants made of natural fibers such as cotton or wool, and steel-toe safety shoes. Hearing protection, hard hats, bump caps, and metatarsal protection may also be required for additional protection. Personnel handling and transporting molten metal may require additional specialized personal protective equipment, including leggings and spats for protection from sparks and burns, fire retardant or reflective jackets and gloves, hard hats with face shields to deflect intense heat and flying debris. It's essential that each employee also avoids contact with gloves or boots that have been used with hazardous chemicals. All new employees must be trained on proper use and maintenance of personal protective equipment. Head protection is also required in die casting facilities. Hard hats consist of an outer shell and inner suspension. The shell provides resistance to impact and penetration of a falling object, and the suspension acts as a shock absorber to keep the shell at least 1 inch above the wearer's head in the event of impact. The bump hat is a metal, plastic, or fiberglass cap shaped like a hard hat, but without a suspension system, so it does not provide adequate protection from falling or sharp objects. There are 3 things that every employee should know about head protection. First, Hard hats should always be inspected daily and always after an impact. The shell should be solid, with no cracks or obvious damage. The suspension should be checked for worn, torn, or broken straps or connectors. The shell and suspension should be cleaned regularly so they can be properly inspected. Employees should not put stickers or paint on a hard hat. These changes make it more difficult to see any flaws in the shell. Store hard hats away from heat, impact, chemicals, or sun exposure. Don't put them in the back window of a vehicle or behind the seat of a truck due to possible impact damage. Hearing protection may be a requirement in your facility. The two general types of hearing protection available are earplugs and earmuffs. Earplugs are ideal. They fit into the ear canal and provide a snug cushion against noise. Earmuffs are also effective at blocking out harmful noise. They create a sealed space around each ear, but hair, earrings, and eyeglasses can get in the way and limit their effectiveness. Personal stereos with headphones are no substitute for hearing protection and should not be used. Hearing protection should be inspected daily and be cleaned, repaired, or replaced as needed. Foot injuries in die casting can be common and quite debilitating. Protective footwear made with a steel reinforced box toe protects the foot from being crushed. Safety shoes and boots should also have puncture-resistant soles. Work around chemicals may require rubber or synthetic footwear. Toe caps, foot guards, and heel and ankle shields are also available for use in areas of work requiring extra protection. It's important to check safety shoes on a daily basis for wear, cracking or drying of leather, damage to grommets or fastenings, and damage to the soles. If shoes have steel toes, check inside the shoes to be sure the metal is not protruding from the lining. Hands, fingers, and arms are injured more often than any other body part. The causes for those injuries include sharp edges, contact with chemicals, pinch points in equipment, abrasions, temperature extremes, and contact with electricity. Like footwear, proper fit is important with hand protection to allow for full movement and dexterity. Precautions to take when choosing the right hand protection include taping the top of the glove or sleeve or folding it to form a cuff to prevent chemicals from running down the arm and inside the glove or sleeve. Vinyl, rubber, or neoprene gloves are good for use with most chemicals. A synthetic glove is required when working with petroleum-based chemicals. Metal reinforced gloves provide the best protection from sharp points or edges, but do not wear gloves containing metal when working around electricity or electrical equipment. Leather or cotton gloves are best for handling abrasive materials. Avoid using gloves when working around machinery, as moving parts can easily pull a hand and arm into the machine. Remove gloves or sleeves to avoid contaminating skin, clothing, or surroundings with anything on the outside of the glove or sleeve. Always inspect hand and arm protection daily. Look for holes, splits and seams, evidence of corrosion, or other evidence of wear and damage, and replace damaged gloves immediately. Safe work habits are essential to all personnel, especially for those who work with the handling of molten metal. Handling and transporting molten metal can be very dangerous. Reverberatory furnaces hold large quantities of molten metal, from 2,000 to as much as 100,000 pounds. An explosion in one of these furnaces, caused by water or other liquid submerged in the metal bath, can cause a disaster. One of the worst die casting disasters of all time happened because safety procedures weren't followed. In this explosion, a 230-foot-long manufacturing facility was reduced to rubble in minutes. This accident was caused when a closed container of liquid found its way into a scrap casting hopper, which was then deposited into a reverberatory furnace for remelting. The container of water, submerged beneath nearly 50,000 pounds of molten aluminum, expanded 2,500 times. Changing to steam, the water vaporized the molten aluminum, resulting in a massive explosion. 1 pound of molten aluminum has the explosive capacity of 3 pounds of TNT if water becomes trapped beneath it. That's a worst-case scenario. This furnace explosion resulted in the death of 2 workers. 14 others were seriously injured. The explosion was heard 55 miles away. Here's what was left of the plant the next day. Proper storage and handling of raw materials such as scrap, ingots, sows, and fluxes is critical. Die casting metals must be moisture-free before being charged into a melting furnace. Safety rules for working with molten metal must be established and rigidly enforced. Never charge anything wet into molten metal. Materials to be melted should be preheated to evaporate any moisture on the surface or trapped inside the metal. No plastic bottles, water-based fluids, cans, or aerosol stored or used around molten metal or furnaces. Hydraulic and lubricating oils, dye lubricants, water, and other liquid materials should be contained to avoid mixing with molten metal. All tools used for working with molten metal should be properly treated to prolong the life of the tools, to prevent contamination of the molten metal, and preheated to at least 300 degrees Fahrenheit before usage to eliminate moisture from the tool. The coating should not contain calcium, which reacts with molten metal. Scrap materials, sows, and ingots should be preheated to a minimum of 800 degrees Fahrenheit prior to being introduced into molten metal baths. To prevent burns, assume that all metal and equipment around the furnace is hot. Safety glasses with side shields must be worn. Safety clothing must be made of natural fibers such as cotton or wool. Polyester or other synthetic-based clothes melt quickly and will stick to the skin. Aluminized coats, gloves, spats, and leggings, heat-resistant gloves, and fire-retardant jackets should be worn at all times, along with hard hats and face shields. Beware of heat exhaustion. Melting furnace areas can reach 120 degrees Fahrenheit. Know the symptoms of heat exhaustion and take proper precaution to avoid this condition. Don't risk having an accident and seek medical attention if you experience the symptoms of heat exhaustion. Toxic substances can exist in the die casting workplace. In metal melting and holding furnaces, zinc, lead, tin, and fluxing chemicals create toxic fumes. Training in toxic substance handling is mandatory. Employees should avoid breathing furnace fumes. In 1974, OSHA adopted machine guarding regulations. The standard requires that any machine part, function, or process that may cause injury must be safeguarded to protect employees. Machine parts that rotate, slide, changes elevation, or intersects with other parts of the machine. In a nutshell, if it moves and could cause injury, it must be guarded. There are 3 areas on a machine that create a hazard. The point of operation where the work is done, such as casting, cutting, shaping, boring, and forming. The power transmission apparatus is the device that transmits power to the machine. Flywheels, pulleys, belts, couplings, spindles, chains, cranks, and gears are typical components. Other moving parts of the equipment, like the closing of a die in a die casting machine and the shot cylinder, moving to force molten metal into a die. There are several hazards inherent in die casting machines that must be guarded, like the toggle linkage, which moves the die open and closed and provides locking tonnage prior to metal injection. The injection sleeve and tip, which provides the power and speed required to inject molten metal into the die. The safety ratchet prevents the machine from closing inadvertently. The operator's door, which shields the operator from hazards during the metal injection portion of the cycle. In a horizontal cold chamber die casting machine, molten metal, ladled into the pour hole of the shot sleeve, may splash onto the shot sleeve and freeze. An operator should never attempt to brush away these drippings with his hand or place his finger in the pour hole. Metal drippings must be removed with a tool, such as a metal scraper. Occasionally, the injection plunger tip of a cold chamber machine will seize in the shot sleeve. There are safe procedures for removing the stuck plunger, and they must be adhered to even if they are time-consuming. Fixture designs can be implemented to safely hold a bar between the die halves to force out the stuck plunger. Placing a pipe between the open halves of the die and holding it with your hand while closing the machine to force out the plunger tip is an unsafe procedure and must not be used. If no provisions have been made for safe removal of stuck die plungers, shut the machine down to a zero-energy state with the die open to remove the cover half of the die. Disconnect the plunger rod, remove the cover half of the die, and remove the plunger, rod, and shot sleeve. A removable retainer will ease the removal of the shot sleeve to access the stuck plunger without the need to remove the cover half of the die. Hot chamber die casting machines use a nozzle called the gooseneck to transfer molten metal from the pressure chamber to the die. Excessive pressure can deform the sealing gaskets at both ends of the gooseneck and can cause the nozzle to leak. When this leakage occurs, the molten metal may spray out of the nozzle, creating a burn hazard. Molten metal can spit from the die parting plane at a high velocity during metal injection. Safety gates and operator doors should be installed and properly maintained on all die casting machines, and spit guards mounted on the die block will stop the flying metal. A bursting biscuit occurs on a cold chamber machine if the metal in the die is not adequately solidified when the die opens and while the plunger continues to apply pressure to the biscuit. The explosion will send molten metal around the machine and can cause severe injuries. Properly designed and installed safety doors guard against this hazard. Safety doors should also be interlocked to the machine operation to prevent opening until the die has opened. An operator's door prevents entry to the machine when it's operating and protects the operator from metal spitting at the parting line. Closing that door should be easy, and the leading edge of the door should have a sensing device to stop or reverse the door if it strikes something while it's closing. The safety ratchet has a notched bar that moves with the moving platen or toggle crosshead and prevents accidental movement of the die casting machine closing system. The safety ratchet is normally on top of the machine, so it is a hazard only when someone climbs on the machine. Die casting machines also have chain or gear drives that must be guarded during machine operation. There's a space between the mechanical bumper pin plate and the movable platen that can present a dangerous pinch point. Normally, the linkage area guards will protect this pinch point, but during die installation or adjustment, the machine must be shut down and placed in a zero energy state. The injection hydraulic and die closing cylinders of a die casting machine are usually operated with an accumulator hydraulic circuit. Since the accumulator is under extremely high pressure, a leak or a shift of the valve could cause the cylinder to move unexpectedly, even when the machine is locked out or the pump is off. Newer die casting machines automatically depressurize the accumulator when the machine is shut down. It's essential that procedures be adopted to put the machine in a zero energy state condition before any type of maintenance work is done. High-pressure hydraulic systems on die casting machines also utilize special hoses. These hoses should be regularly inspected for wear and, when required, replaced with equal quality hose material. Avoid padding hoses that rub against each other or against other parts of the machine to prevent abrading. Restraining these hoses with chains or other means prevents hoses from whipping around if they were to ever break or rupture. And even though modern hydraulic fluid is fire-resistant, it's not fireproof. When hydraulic fluid comes in contact with high-temperature sources, such as molten metal, it can burn. All machines should be equipped with dual-button close controls that require the operator to start the machine using both hands. If the machine controls are mounted on a movable pedestal, the pedestal should be far enough from the opening and closing of the machine to prevent the operators from entering the die area while manipulating the controls. Electrical controls like open electrical boxes and loose conduit connectors can also be hazardous to employees. Electrical control panels have interlocks for protection from high voltage. It may be necessary to bypass the interlock for troubleshooting with management approval and safety precautions, but never deactivate limit switches or interlocks without proper approval. Electrical safety should always be a priority in any operation. Only qualified personnel should be allowed to work on electrical systems. Arc flash and electrical shock can severely injure and kill employees who don't follow electrical safety standards. Varying types of electrical gear and clothing are required to protect the individual performing these operations. Before any electrical work is started, the machine must be locked out and/or tagged out, and the machine placed in a zero energy state condition. Changes should not be made to a wiring layout without full prior consultation with the machine builder. When a wire is disconnected, it must be identified with a tag to avoid improper reconnection. If disconnection is temporary, wires must be guarded and disconnected from feed wires. Simple changes to an electrical layout can result in extremely hazardous conditions when the machine is powered up. All electrical tools must be grounded or double insulated. Check for loose electrical conduits and fittings, and for broken or frayed wires. Personnel should not use flexible or rigid electrical conduit as a stepping or standing place. Die casting dies can be very complex with many hazards, such as the ejector plate of the die moves the ejector pins forward to eject the casting from the die. This motion can create several pinch hazards under several circumstances. Die parting spit, which occurs when molten metal leaves the die cavity at high speed. Coarse cylinders and slides, which present motion and pinch hazards as the die opens and closes. Angle pins, which can create snag and pinch hazards while the die is in operation. Ejector pins, which can snag clothing or cause lacerations to the operator who is working in or on the die. Stuck castings. Cast-in inserts, which must be placed manually in the die while it is in production and while the die is hot. Core slide springs, which are compressed as the die closes and create potential energy that can present hazards. Whenever entry into the immediate die area is required, the machine should be placed in a zero-energy state by turning off the main power, blocking the die open, blocking or removing the injection ram on hot chamber machines, depressurizing the accumulator and the machine. Many types of auxiliary equipment are used in modern die casting operations, sometimes as part of a die casting cell, where pieces of equipment are interlocked and function as an integrated production system. Areas to pay attention to in order to ensure safe operation include the mechanical ladle area, hydraulic trim presses used to remove runners, flash, and gates and runners from the castings, extractors, areas which move parts out of the die casting machine and into other post-casting operations, have mechanical extracting arms that swing vertically and horizontally. Personnel should not enter these areas when the equipment is operating. A gate for entry of setup and maintenance personnel must be interlocked with the machine control circuits to stop the machine when the gate is opened. Pits are fall hazards and must be properly guarded. Conveyors have a variety of pinch or snag hazards and obviously should never be ridden. Only authorized employees who have been thoroughly trained should use cranes and hoists, and it's best to use a spotter to watch